doesn't have to make for me. But from what I've heard, they're not very negative with the data that we get from them.
Do you know their technology? No. Are they fence line or?
Yeah.
So, I guess we're recording now, so it's, you be careful what you're saying. I'll jump in a minute. Is it 4 already? Just after 4. Just after 4. So, as a quick introduction, one of the things, if you might be interested, there's these guys already know, obviously, Kirk works for me. My name's Chris Braille. I'm with United Electric Controls. That looks like me, I hope. We're based out of Watertown, and we've been in business for about 90 years. And so what we're known for is pressure and temperature switches primarily. So these are old school spring-loaded mechanical devices that can turn on and off processes based on the temperature and pressure. And we've more recently moved into more electronics-based equipment. About 2015, we started working with a customer, and it became a couple of customers on this gas detector and bringing it to market. But it's been very slow to take up. And this discussion is really about what were some of the barriers for gas detection, for wireless gas detection, I should say, up to this point. What's going on now in industry and how these, it's very application-less discussion and less so on product. One of the things, if you're interested in learning more about the prototype that we're going to do, it's probably geared a lot more towards trying to get more data points and get more density, which is something we need for emissions. Whereas a lot of these applications are wireless, it's really focused around safety applications. So it's really the primary difference from the interest. Where we got started was, when it's a new product line, you have limited visibility on what's available out there. And the customers we worked with had a large installed base of wireless, but it was mostly around process control instrumentation. So the reason in process control instrumentation that wireless became so popular is during startup and shutdown operations, they really need to have a lot more instrumentation to understand what's going on in the plant. Like to plumb in a pressure sensor or a temperature sensor to see what's going on in a particular line during those startup and shutdown would have cost too much when we only need it for that short period of time, once every 5 years or 10 years when the turnarounds happen. So they've limited wires. They want to be able to put these in, take them down. And so in process control, they were used a lot for those kind of startup. The biggest issues with wireless initially was the fact that you had a lot of proprietary protocols. Battery technology wasn't quite where it is now. There was reliability and security concerns with these proprietary aspects. But there was still the ability to really reduce the cost of implementation, get those lot data points, and make better decisions with that data. So it was highly scalable. And what came along later to try and make it more accepted for process was the fact that things like wireless HART and ISA 100 standards came out. So now all vendors could now use one protocol. We got 2 vendors right here. And be able to plumb into those operations just like anything else. All of us have cell phones. You start seeing a lot of electric cars. The battery technology has gotten a lot better. And now they're seen as permanent devices. You actually can go to Emerson's site over here. Their booth is near ours. You'll see about 4 or 5 different devices there that are permanent installed wireless battery operated devices. So the question is does that pertain to gas detection? And of course, we're going to say yes, because that's why we're here. And it's all the same reasons, for safety and LDAR, and now starting to come in a lot more as emissions specific for regulations, is need to make better operation decisions. What do we need to fix? When do we want to fix it? How quickly can we get to it? What are the worst places? Where do we need to get people out very quickly from a safety standpoint? You have all these AI algorithms that are trying to do a lot more with the data. They need more data points or smarter data points than what they have. And wireless can be very scalable and simple to install. You don't have to run all the wires, which would be significantly expensive. Process instrumentation, sometimes you need those to be a lot faster. So they want to take the limited resources that might be available in plants. So the safety apparatus tends to have to find a different route back to the DCS. And even engineering costs and permitting costs can be prohibitive for getting the number of data points you want. But what's driving it is you get a lot more remote areas, unmanned facilities, regulations, and they're really trying to keep plants operating on their own, minimize operating costs. So to build a robust system, you should start with a standard or something that multiple manufacturers can do, wireless hard, ISA, third-party verifications, using that mesh capability of wireless to be able to be robust and secure. And one of the limitations around gas detection has always been the reluctance of industry to take on, it's a laggard community like purposely, it's safety, it's risk averse. You want to make sure that battery life is going to be last long and sensors are smart enough to tell you there's a problem and it's not that you need to go out and take care of it. So in the wireless gas world, you're starting to see that shift, but there's still a reluctance of customers to move in that direction from a safety standpoint. Traditionally, wire detectors sit up here at incident. So you have a rupture, you have to detect the gas, mitigate the problem before it becomes an emergency response. So you contain, isolate, you go address that leak before something blows up. Or in the case of toxics, somebody gets hurt. One of the other benefits, so this is typically attached to some like a safety system for wired systems. For wireless, what a lot of customers are looking at is how do I mitigate those problems long before they become an incident? How do I prevent that something happening from a burst line or something along those lines where a gas can completely lets go? And they're finding that being able to move that decision sooner, they can actually address that or mitigate that problem or triage that problem effectively. They might be concerned about a thinning pipe because there's erosion going on inside the pipe because there's sediment. So over time, that might be an issue, but right now it's not, but they don't have a detector. They put a detector there, they can get a much earlier indication of that, hey, there's a pinhole. There's getting a little bit burst of gas coming, maybe we're gonna get there, it becomes a full-on rupture. So that's a good example where wireless gas detectors are being used. So there's actually some guidance put out by ISA right now, how to integrate, the use of gas detection in sort of fire gas systems. That's more on the incident. And then there's the guidance, TR 8408 back in 2017. I like to reverse those numbers for non-sys level gas detectors, including the use of wireless gas detection. These are at ISA put these together, and their guidance and support for the NFPA is, just the US. But those standards are actually using both. So this is where a lot of the applications we're going to talk about are sitting. It's basically guidance for an independent protection layer. The whole idea being that problems detected, they have to decide if they're going to do anything or triage it and wait and see if it becomes a worse issue. I think we're here to 4:45. I'll go through a few of these, but then because most of us know what's going on, I'd love to hear some of your thoughts on what you think you need from gas detection and get the talk from there. But some of these use cases all have kind of the similar themes you'll see down here: scalability, time to implement. This customer was able to save almost a half a year in implementing the solution because of the fast deployment, and they saved almost a $500,000. So they had acquired an adjacent facility, and when they bought it, they found out there was no detection equipment there. And to do so, because it was isolated from their main plant, to do trenching would be prohibitive. So running wires out there would probably cost them tens of thousands of dollars per detector to run. And so they wanted to become compliant with both community and plant facilities. So they wanted to deploy that fast. So they were able to put these detectors in. I think we should about a couple of weeks, and they were able to install it, whereas their original engineering had projected out about a half year. They did have existing wireless HART infrastructure, so they were able to just plug into the existing gateway. This was an interesting one on H2S. They basically had frequent leaks from this flange right here. And the way they would discover it wasn't the gas detector that was on the other side of the valve pump. The problem was the predominant wind direction was away from the gas, but it was wired in, and they were going to actually have to spend about $30,000 to move that equipment to the other side. So they bought this gas detector to actually just be able to put on the other side of the detector, because it was about once every year or two they would have someone by, distinct smell of presence of H2S. They would go out with their sniffer and they would find that it's leaking, but the gas detector wasn't picking it up at all. So they were able to put this in pretty quickly, never shut down the application, and because it was a wireless device, they could shift it to the optimal position after they put it based on what their operational condition was. So unfortunately, the picture, they didn't capture the devices actually sitting right here off screen.
I wonder why they didn't mount it lower.
Yeah. And actually, I think it was the angle of the shot.
Oh, okay.
Yeah. But yeah, they usually would mount that about, 10 inches off the ground. This is another H2S. This one also confused me too, because they had detectors up high up here, measuring over this equipment for H2S. But this one's lower below this rack. But I was always wondering why that one was way up here. But it was a similar situation here. Not that the gas detectors weren't picking up. It was the fact that H2S was actually getting into the conduit and rotting out the cables for you. And they got tired of trying to maintain conduit. So instead of running all new conduit to make sure that they had taken care of all the leaks in the conduit, not in the process, they went with the wireless detectors to get more reliability in their safety system. So this was kind of one that caught us off guard, that we weren't aware of this problem when we developed it, and the customer was ecstatic that they didn't have to go through and do that. They replaced all their wire with wireless H2S detectors, which is kind of the opposite thing when you think about the concern of wireless was always that it was less reliable. This is a major oil company here in the US. They actually had a situation where their plant was expanding. They didn't necessarily have gas detection here, but this neighborhood was never there. The neighborhood grew up over time. And because of that, they needed to make sure that they were monitoring this fence. And there's some tanks here and additional ones over here. In fact, this is an older picture, because I think they have a couple of more new ones. But they wanted to make sure that at any given time, they were aware of anything that would drift across that road into the neighborhood. And because of its location, and there's no infrastructure here to wire in gas detection, they ended up placing them most up here from their studies. But doing a wired system was something that they could never justify cost-wise. So they were getting ready to kind of bite the bullet on it. They tried out the wireless ones. We never had one wireless. Again, They saved over $1 million in implementation by going with these. No disruption, it was very fast deployments. You see that constantly with it. This is terminal monitoring. Again, limited wiring. These are isolated, sometimes on-demand facilities. They want to make sure that anytime one of the pumps shows a leak, that the headquarters is notified, they can deploy a tech, but it also instantly shuts down that pump. So they use it for actual shutdown in this particular case. So they actually have several terminals throughout the area, and they deploy those quite frequently.
What's the gas up there?
Sorry?
What's the gas?
Nothing.
Okay.
Yeah. This was one of the missions ones that we did. And this was kind of an interesting one where we did a test study. I'm trying to think which company it was. I think it was Scientific Aviation did one where they talked about trying to test out doing 4 detectors around the box, around one of these well pads. This is a Christmas tree that they're actually using for underground gas storage. So it's been used up wells, now they're pumping the gas in for storage. And they wanted to make sure that they were monitoring for super emitters. So they're not looking for micro leaks, but they're making sure that they're not poisoning neighboring neighborhoods. So the original test that we ran with them, because it was small, it was prohibitive to do the modeling, is we did the 4 points. We ended up doing with 2 detectors on each one of these because of the prominent wind. But they put these detectors all throughout all these trees to monitor for those super emitters. They use that for the reporting purposes. One of the things that we've come to learn here is that most customers are actually looking for a much lower capability because these are NDIR sensors. So when looking for a super emitter, it's fine, but looking at LDAR is ppm and ppb levels of gas, and this is tens or hundreds of ppm. So we tend to not do emissions as much, but it's obvious it's on the levels of interest. So this is probably closer to what you do. We'll use that for monthly reporting, quarterly reporting, and it's working out pretty well for them. The actual benefit of the wireless in this case was the fact that they were out of compliance. They were able to hit an aggressive 3-month timeline for implementation that they couldn't do with wire detectors. And the other things that they were using weren't working as but if from the emission side, I would recommend talking to kind of the Baker Hughes and Scientific Aviation and the Molex guys as well, because what they're doing is a tiered multiple level thing. And then you can incorporate something like a fixed point to supplement some of the other technologies. And one of the interesting ones, I don't know if you've seen this as much. We have a customer who's actually using a lot of these as deployment for long-term triage. So there was a concern that this flange here would leak from time to time. And their turnaround was in 3 years. So what they wanted to do was monitor that flange to make sure it didn't leak. Instead of where they would have to send up someone to the top of the tower manually to check it from time to time, on a daily basis, actually, is what they were doing. So they put that there. They were able to successfully verify that there was no leaks happening. There's actually a wire detector on the other side of it, so it's supplementing that. The fact that they could leave it there for 3 years, they were very happy. So they're actually using these more and more often to kind of fill in gaps, long-term hot work areas, things that area monitors can't do. And they're actually now starting to convert over to using these instead of wire detectors just because of the ease of operation. So their original need was that precise location and that long term. And this is, again, same story, fast deployment, no disruptions, limited wiring. This is a paint facility and they had a lot of solvents in a tank farm. It was downhill from the plant, crossed from a railroad track. So they couldn't run wires under or over that railroad track. They have a nice little forest here to make it easy for us to get a Wi-Fi signal through, wired signal. So we were able to deploy this, and this was one of the examples where we're actually supplying gateways as well as devices and helping with the implementation of that. And now they're copying this sort of approach with multiple sites.
Who's,
This is a PNF.
you know,
Yeah, they're no longer going to be supporting that after this year. I don't know if you guys are aware of
I don't know what PNF is.
that. Pepco tubes.
Oh, yeah.
Yeah,
Sorry, gotcha.
Yeah. They've discontinued this one, so we're looking at supplying others now going forward. Yeah. Do you know somebody who makes one?
Yeah.
Take a look around your total one.
Yeah.
I don't know if you know what we like, make that like in-house. I don't know.
Yeah, with
Smaller ones.
I've never seen it.
Yeah, it's 1410.
1410 and 1420. Yeah. And you also have one that Cisco.
Yeah.
And this is just another one. They actually are concerned about leaks within the insulation up here. There's ductwork on the other side. What they do is they actually have a cooling point and they bring a lead down to the sensor itself. This is propane, right?
Yes.
And they bring it down to the detector, almost like a sample system tube, and verify that. So the goal of this was really to talk primarily about how customers are implementing it in case there's still reluctance. Doing that for safety. That's kind of where the discussion is kind of more of a high level. This is the detector that they use for all of them, which is ours, which is orange device there. And we do have a prototype one over there that is really designed to be a lot more compact if you're interested in looking at that.
And does that sensor connect to UPS or is it kind of its own?
Yeah, so the detector itself essentially just is reading the sensor. There's some conditioning, not a lot done at the device level. That information is transmitted wirelessly to wireless heart through a gateway. That gateway can be connected to whatever the end user's using. So PLCs on the other side, SCADA systems, DCS, or in a couple of cases it goes to a cell module to the cloud to like the paint one, it goes to their online cloud system, which is Ignition. It's definitely scalable for just about anything out there. Most of the gateways will do either Modbus or MQTT, which are all sophisticated standards. And the technologies we use actually for the sensing elements are the same that you'll find in a standard fixed point detector. So for the LELs, we'll do a NDIR sensor that's basically looking at a spectral line. And when the gas goes across it, the absorption level is proportional to the amount of gas that's present. And it's specific to a type of gas. Methane for one, and then actually the hydrocarbons are done by two lines that we look at. The toxic ones are all electrochemicals, so they deplete over time, so they don't last as long as the NDIR. They tend to need to be calibrated more, and they need to be replaced every 2 years. Or if it sees a big event and detect a lot of gas, it's going to deplete it faster.
Yeah.
That's the other thing to consider. So the technology at its core is actually very mature. And also the wireless heart for the process is really mature, and that's why it's starting to gain its acceptance in the safety. So I flew through that as quick as possible because I know it's late. But I also, given that we already all know each other, I keep looking at you, and I sorry to put you on the spot. I hope you're enjoying your popcorn.
Yeah.
But, from the environmental side, I mean, did you have any questions in regards to it? Gas detection or?
Not really. I don't know much about our system. I know we have fence line sensors and then I was told that there was a lot of noise with them, so the data that we ended up recording might not be as accurate, but I don't know like the details on it.
Yeah, you don't know if it's like TLDAS or OGI, OGCI or something like that.
No, I just wanted to come and check it out, see if anything rings a bell and
Which state is it from?
Washington State.
Okay.
He's like, you might know what's there.
What the hell?
You might know what's there.
Oh, yeah.
Yeah. So,
Who does not speak
yeah, so. If you want, I grab my information, I recommend you grab, Jesse's information too, but, we would be willing to talk to anybody there. Is what sometimes happens with these is the deficiency of one technology is picked up by the other, so cameras and whatnot. Interpretation of signals, if they're older, the newer ones tend to have better algorithms that get better imaging. But one of the limitations a lot of them have is if you have bad weather events, you know, heavy fog and snow, might fall off for a while, smoke. I don't know, have you had any smoke lately? I know in Massachusetts, we've had some California smoke, so.
Yeah, this year hasn't been as bad yet, but last year was
Yeah,
pretty bad.
yeah.
for a while.
Wow. It's awful, but yeah, so any one of these things could potentially throw off and cause noise, so without knowing the specific circumstances. Looking at a variety of technologies might be a solution, and that's what some of these folks have been, talking about.
Mhm.
You know, especially even when you think about the, you know, satellites have a lower limit of detection, airplanes, drones, cameras, and then you start getting into fixed point sensors, getting that lower level of detection.
Mhm.
And then the folks with the handhelds, it all complements, and there's some overlaps, and it just depends on what problem you're trying to solve.
Yeah.
And get after that, so. Yeah, we'd be happy to talk to anybody, sure, the Emerson guys would be happy to talk to anybody. So that's kind of the only recommendation I can.
No, that sounds good. Yeah, well, I would grab your cards. Yeah, I'm on the reporting side now.
You probably have to get one of my cards from.
But all the table,
Yeah, this table. Not having a table.
oh, you want to come check out the booth?
Yeah, I'll have to get you one of the cards from them.
Thank you.
Thank you.
Thanks.
Thanks, Chris.
Thank you.
Did you get sick on a month?
No.